about the Coulomb's law in electrostatics. Last class we have already discussed the static electricity and the properties of the static electricity. Now we shall discuss the Coulomb's law in electrostatic, its statements and explanation. To see the statements, Coulomb's law in statement. Coulomb's law satisfied only 2-point charge. Coulomb's law satisfied only 2-point charge. You know, previously the same charge repels each other and unlike charges attract each other. That means positive charges are repelling each other and negative charges attracting each other. The attraction or repulsion exists between the 2-point charge, and the force, the magnitude of force is the magnitude of force. Today we find the magnitude of attractive force and repulsive force. What is the statement? The statement is Coulomb's law in electrostatics states that the magnitude of force of attraction or repulsion between 2-point charges let it be the 2-point charges Q1 and Q2 separated by distance R. The statement is, it states that Coulomb's law in electrostatics states that the force of attraction or repulsion between the 2-point charges is directly proportional to the product of their charges and inversely proportional to the square of the distance between them. It states that Coulomb's law in electrostatics states that the magnitude of force of attraction or repulsion between the 2-point charges is directly proportional is directly proportional to the product of two charges inversely proportional to the square of distance between two charges. ताहले पिलाने स्टेटमेंट कौन है पहला ना Coulomb's law in electrostatic states that the magnitude of force of attraction or repulsion between two charged bodies or between two charges is directly proportional to the product of their charges and inversely proportional to the square of distance between two charged bodies. The force of attraction or repulsion, positive, if you place two positive charges, then there is force of repulsion, and if you place positive and negative charges, then there will be force of attraction. Now, explanation of Coulomb's law of electrostatic. Consider two point charges of charges q1 and q2 placed at a distance r. If the 2 point charges are positive in nature, then there will be force of repulsion. If the 2 point charges, one is positive, another is negative, then there will be force of attraction. Now, if these two charges is positive in nature, then there will be force of repulsion. This magnitude of force of repulsion, according to the Coulomb's law, this F is directly proportional product of the two charges Q1 and Q2, and F is inversely proportional to the square of the distance between two charged bodies, between the 2 point charges. These 2 point charges separated at a distance r. Now, combining these two, we have F is proportional Q1 Q2 by r square, and or F is equal to some constant beta Q1 Q2 by r. Now, beta is called the constant of proportionality, and its value depends upon the nature of 2 point charges placed. In CGS system, the value of beta is in CGS system the value of beta is 1 by k. K is the dielectric constant. K is the dielectric constant. Then F is equal to, you can write 1 by K Q1 Q2 by R. Q1 Q2 by R. Then K is the dielectric constant. This K is the dielectric constant. The dielectric constant is defined as the ratio of the force between two charged particles separated by some distance apart in free space to the force between same two charges separated by a distance apart in that medium. The dimension of the dielectric constant is no, there is no dimension of the dielectric constant. That means dielectric constant is dimensionless. Dielectric constant is dimensionless. Constant. In free space or air, the value of dielectric constant in air, the value of K equal to 1. Then F is simply Q1 Q2 by R square. Q1 Q2 by R square. In CPS system, in SI system, in SI system, the value of beta is equal to 1 by 4 pi epsilon 0 epsilon. Epsilon 0 is the electric permittivity in free space and epsilon r is the relative permittivity. Then putting the value of beta, F will be 1 by 4 pi epsilon 0 epsilon r Q1 Q2 by R square. Air or free space, the value of relative permittivity, that means epsilon r is equal to 1 in air or vacuum or free space. Then F is equal to, simply you can write 1 by 4 pi epsilon 0 Q1 Q2 by R square. The value of epsilon 0 is equal to 8.854 into 10 to the power minus 12 Coulomb square Newton inverse meter inverse. The value of electric permittivity in free space is 8.854 into 10 to the power minus 12 Coulomb square Newton inverse 2 meter inverse 2. Now putting the value of epsilon 0, that is 1 by 4 pi epsilon 0, that is 1 by 4 pi into 8.854 into 10 to the power minus 12 Coulomb square Newton inverse 2. If that simply 9 into approximately 9 into 10 to the power 9 Coulomb inverse Coulomb inverse 2 Coulomb square Newton meter square. Coulomb square Newton meter square. Now the definition of unit charge. Definition of unit charge. Now putting the value of 1 by 4 pi epsilon 0, that is F will be F is equal to simply 9 into 10 to the power 9 into 10 to the power 9 Q1 Q2 by R. Now the definition of unit charge in series system and SI system. In series system, definition of unit charge. In series system, if F is equal to 1 dyne, Q1 is equal to Q2 is equal to Q and R is equal to 1 centimeter, then putting the value of F is equal to Q into Q1 Q2 by R square, that is 1 is equal to Q into Q by 1 square, that is implies 1 is equal to Q square, Q is equal to plus minus 1. Now the charge, unit charge, the value of Q is equal to 1, that is unit charge. The definition of unit charge in series system is defined as one start coulomb unit charge in series system is that charge, or one start coulomb charge is defined as the one start coulomb charge is that charge which when placed in air at a distance of 1 centimeter from an equal and similar charges repels with the force of 1 dyne. One start coulomb or unit charge in series system is that charge which when placed in air or free space at a distance of 1 centimeter from an equal and similar charge, equal and similar charges repel repels with the force of 1 time. Unit charge in series system or 1 start coulomb is that charge which when placed in air or free space at a distance of 1 centimeter from an equal and similar charges repels with the force of 1 dyne. Dyne is the unit of force in series system. Now come to definition of unit charge in SI system. In SI system, F is equal to 9 into 10 to the power 9 Q1 Q2 by R square. That is, if F is equal to 9 into 10 to the power 9 Newton, Q1 is equal to Q2 is equal to Q, R is equal to 1 meter. Then putting the value of this in this equation, then equal 9 into 10 to the power 9 is equal to 9 into 10 to the power 9 Q into Q by 1 square. That is implies U square is equal to 1, Q is equal to plus minus. Here, the definition of from this Q is equal to Q is charge, that is plus minus 1. 1 is unit. The unit charge in SI system is defined as, or 1 coulomb charge is defined as that charge which when placed in air or free space at a distance of 1 meter from an equal and similar charge repels with the force of 9 into 10 to the 9 Newton. Write down the unit charge in SI system. The unit charge in SI system is that charge which when placed in air or free space at a distance of 1 meter from an equal and similar charge repels with the force of 9 into 10. Now you see the question will ask like this: state and explain state and explain. Coulomb's law in electrostatics and define define unit charge in SI system. Then next class we shall discuss the problems of electrostatics using formula F is equal to 9 into 10 to the 9 Q1 Q2 by R square. Then definition of electric permittivity. Definition of relative permittivity epsilon R is equal to epsilon by epsilon. You see, epsilon R is relative permittivity in free space and epsilon is absolute permittivity and epsilon 0 is permittivity in free space. The relative permittivity is defined as the ratio between absolute permittivity and permittivity in free space. The relative definition question will ask to 2 mark question. Define relativity permittivity. That is the ratio between absolute permittivity, epsilon that is absolute permittivity, and epsilon 0 permittivity in free space. Thank you, students. Next class we will learn the magnetism and properties, magnetic properties and Coulomb's law in magnetism. Thank you.